Hi. In this type of questions, you are required to find the domain, the range, and to represent them using set notation and inequality and interval notation. You are also required to find the end behavior of this function. Let's first define the domain of the function. The domain is defined as the set of x values. So when you are going to define the domain of any function from its graph, you have to look at the x-axis, and the range is defined as the set of y values for any function. So if you have to find the range of a function from the graph, you have to look at the y values, not the x values. Finally, the end behavior describes what happens to y as x increases too much. As x tends to positive infinity, what happens to the values of y? So let's first start with question 5, and given this curve, this curve is called the parabola or quadratic function, and we would like to find the domain, range, and end behavior for this curve. First, we would like to know that this curve, as long as it has arrows, this curve goes to infinity. So we are dealing here with infinite domain and range. So you are expected to find positive infinity and negative infinities in your solution. First, to solve this problem, you have to define your directions. This direction is positive infinity, and this one, the opposite direction, is negative infinity. The direction up is positive infinity, and the direction down is negative infinity. If we look at this arrow in x goes to the right, to this direction. This direction is defined as positive infinity. And if we look at this arrow is going to the left in the x direction, so it's going in the negative infinity direction. But if you are going to write the domain, you have to start from the left to the right. So the starting point from the left is negative infinity, comma, the ending point on the right is positive infinity. And we said before that positive infinity and negative infinity always takes rounded bracket. So this is the domain of this function, and of course you can write it in inequality and set notations. This is no longer too hard for you to do. Let's find the range for this function. The range for this function, and what we see here is two arrows. These two arrows are moving up to positive infinity, up in this direction. So the ending point for the range is positive infinity, and the lowest point of the curve is this point at 2. But when you are going to find the range of the function, you have to look from down to up. So your starting point is, if this is your range, the starting point is 2, and the curve keeps going on up to positive infinity. Positive infinity always takes rounded bracket, and the value 2 is included inside the range because the curve is passing through this value. Here at this point the curve is passing through 2, so 2 is included inside the interval, so we put a square bracket at the value of 2. Finally, to write an end behavior statement, all we have to do again is to look at these arrows. This arrow is going to the right. To the right means positive infinity in x, and it is also going up. Up means positive infinity in y. Y tends to positive infinity. The other one, x goes to negative infinity to the left, and y goes to positive infinity also, because this arrow is going to the left up. So this is what we call an end behavior statement for this function. As x tends to positive infinity, y also tends to positive infinity. As x tends to negative infinity, y tends to positive infinity.